Hello and welcome to this video. This is the 11th set of problems on complex numbers, that is problem number 101 to 110. And as I always say, I'll say that again, that when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So without further ado, let's get started. Problem 101 says that if Z1, Z2 and Z3 form a right angle isosceles triangle with right angle at Z3, then prove that Z1 minus Z2 whole square is equal to 2 Z1 minus Z3 into Z3 minus Z2. So since the right angle is at Z3, the sides of Z2 minus Z3 and Z1 minus Z3 will make an angle of pi by 2, that is, the ratio will be equal to EI pi by 2, which is equal to I. So you take Z1 minus Z3 and multiply with I and square that. You will get Z2 minus Z3 whole square is equal to minus Z1 minus Z3 whole square, which you expand to get this value. And then you bring Z1 to left hand side and you bring Z3 to right hand side. And then subtract 2 Z1, Z2 on both sides. And then it is a simple matter of finding the common factors to get the desired result. Problem 102 says that find the equation of a circle whose center is Z0 and radius is R. So clearly we can say that Z minus Z0 whole square is equal to R square, because any point on perimeter, that is Z, minus center, that distance would be R. So mod of that squared will be equal to R square. So this is equal to Z minus Z0 multiplied with bar of Z minus Z0 is equal to R square. So now rest of it is very simple. And we have the final equation as Z bar minus Z bar Z0 minus Z0 bar plus Z0 bar is equal to R square. Problem 103 says that if Z is equal to 1 minus T plus I square root of T square plus T plus 2, where T is a real parameter, prove that locus of Z in argand plane is a hyperbola. So this is all about eliminating T from the equation. We are given Z is equal to this much. So if Z is equal to X plus IY, then you compare real and imaginary parts. You will get X is equal to 1 minus T and Y is equal to square root of T square plus T plus 2. This should be 2. It's a typing mistake. So we take this and we square. So we get Y square is equal to T square plus T plus 2. And from this equation, we bring T to left hand side and X to right hand side. We know that T is equal to 1 minus X. So we substitute T is equal to 1 minus X in this equation, that is Y square is equal to 1 minus X whole square plus 1 minus X plus 2. Now we put this in the form such that it will represent a hyperbola, which is X minus 3 by 2 whole square plus 7 by 4. So you will have to know a bit of coordinate geometry to understand why this equation represents a hyperbola. Sorry, not parabola. This is a hyperbola. Yeah, it's a typing mistake again. Find the locus of Z if Z bar is equal to A bar plus R square by Z minus A. So just like we have found the equation of circle, we can say that we take A bar to left hand side, we get Z bar minus A bar, and then we multiply that with Z minus A. We get Z bar minus A bar into Z minus A is equal to R square, which is the equation of circle we have just found for the Z0 and R square case. Problem 105 says that if the equation mod of Z minus Z1 whole square plus mod of Z minus Z2 whole square is equal to K represents the equation of circle where Z1 is equal to 2 plus 3i and Z2 is equal to 4 plus 3i are the ends of a parameter diameter, then find the value of K. So if Z1 and Z2 are ends of diameter, then you assume a circle, you have diameter and a point Z on the perimeter, that is then diameter will make an angle of pi by 2. So it will be an equation that is mod of Z minus Z1 whole square plus mod of Z minus Z2 whole square, that is the two lines which will join any point on perimeter from the end of diameter, that is these two distances, will be equal to the diameter square, that is Z1 minus Z2 whole square. So our K from the equation on comparison is equal to mod of Z1 minus Z2 whole square. We substitute the values of z1 as 2 plus 3i and z2 as 4 plus 3i. 3i will get cancelled. 2 minus 4 is minus 2. Square of that will be 4. Problem 106 says that if mod of z plus 1 is equal to square root of 2 multiplied with mod of z minus 1, show that locus of z is a circle. So we let z is equal to x plus iy, then we substitute this in the given equation. We get mod of x plus 1 plus iy is equal to square root of 2 mod of x minus 1 plus iy. So we square both sides. We get on left hand side x plus 1 whole square plus y square, and on right hand side we will get 2 into x minus 1 whole square plus y square. Now this will give us x square plus y square minus 6x plus 1 is equal to 0. Now if you want to further evaluate this, it can be written as x minus 3 whole square plus y square minus 8. So 8 will go on right hand side, which will be 2 square root of 2 whole square. So this represents a circle with center at 3, 0, that is on x-axis, with radius 2 square root of 2. Problem 107 says that prove that locus of z given by mod of z minus 1 by mod of z minus I is equal to 1 is a straight line. So we are given that this fraction is equal to 1, so we can write mod of z minus 1 is equal to mod of z minus I. So like previous example, we substitute z is equal to xy and square both sides. We get on left hand side x minus 1 whole square plus y square, and on right hand side x square plus y minus 1 whole square. So x square will get cancelled, y square will get cancelled, 1 will get cancelled. On left hand side we will have minus 2x, on right hand side we will have minus 2y. That is 2x is equal to 2y or x is equal to y, which is the equation of a straight line. Problem 108 says that find the condition for 4 complex numbers z1, z2, z3 and z4 to lie on a cyclic quadrilateral. So this is the condition for 4 points to lie on a quadrilateral, that is a cyclic quadrilateral. So we have 4 points A, B, C, D. This should be z4, that is z1, z2, z3, z4. So if you look at angle z1, it would be z1 minus z2 by z1 minus z4. This is the argument of that, z1 minus z2 and z1 minus z4. Similarly, argument 2 would be z3 minus z2 and z1 minus z2 and so on. So these are the 4 angles. Now we know that the sum of opposing angles in a cyclic quadrilateral is equal to 180 degree or pi radian, that is this much. So we just substitute the arguments of those and then you equate that to pi. So you will arrive that this fraction should be a real number for cyclic quadrilateral condition. Problem 109 says that if z1, z2, z3 are complex numbers such that 2 by z1 is equal to 1 by z2 plus 1 by z3, then show that these points lie on a circle passing through origin. So what this essentially means is these 3 points and origin, the 4 points form a cyclic quadrilateral. So we are given that 2 by z1 is equal to 1 by z2 plus 1 by z3. So you rearrange these terms, you will get z2 minus z1 by z3 minus z1 is equal to minus z2 by z3. Now we take argument of both sides. We get argument of z2 minus z1 by z3 minus z2 is equal to pi minus arg of z3 by z2. So we can write z3 by z2 as z3 minus 0 divided by z2 minus 0. The sum of these 4 points, sum of these 2 arguments will be equal to pi. Thus, z1, z2, z3 and origin are concyclic. Problem 110 says that if z minus omega whole square plus z minus omega square whole square is equal to r square, where r is radius and omega square are cube roots of unity and ends of diameter of the circle, then find radius. So like the previous one which we have solved, we can say that z minus z1 mod of z minus z1 whole square is equal to mod of z minus omega square is equal to r square is equal to mod of z1 minus z2 whole square. So we substitute r square is equal to z1 minus z2. So z1 is omega and z2 is omega square. So we substitute that. So this would be the value of omega minus omega square would be I root 3. You square that and then that will be equal to 3 or r is equal to root 3. Now, if we substitute omega square minus omega, that is the other way around, then this would be minus I root 3, but the end result will be root 3 only. So with this, we come to the end of 11 set of problem. In the next video, we will solve 10 more problems. That is the 12th set of problems on complex numbers. So stay tuned for the next video. If you have a comment or you want to say something, or if you find any other mistake other than what I have found, please leave me a comment, and I'll ensure that I take care of your suggestion or improvement or comment. If you found this video useful, please subscribe to the channel and like the video so that the reach of video grows and many other students like you can benefit from this. Thanks a lot for watching. Enjoy.